The Marine Tech Expo is going virtual this year. Welcome back to the final session of Marine Tech Expo from the UK's ocean city of Plymouth. Sustainability has been the theme today, and we've looked at some of the technical solutions being developed to help the marine sector become greener. But how do we measure the success of that work? Well, that's where smart monitoring comes in. To get our final session underway, we're joined by Samantha Lavender from Pixelytics Limited to talk about supporting sustainable marine activities through innovations in satellite Earth observations.
Hello, my name is Dr. Samantha Lavender, and I'm going to talk about innovations in marine Earth observation that are supporting sustainable marine activities. So one of the key activities that have been occurring in the space and more specifically Earth observation sectors is that there's very much more data available. So when we look back maybe 10 or 20 years, it was very much a limited number of satellites in space. And so you could get data, but you often had to task the satellite to acquire specific data sets, or you might only get infrequent data sets. Nowadays, we have much more systematic coverage, and it actually maybe has even got to the point where there's more data than you can deal with a lot of the time. And so very much computing is becoming important in terms of handling those large data sets, specifically in the cloud. So you're not downloading large amounts of data, but rather taking your code to where the data already sits. But also it starts to allow you to have a look at varying features over time, over much shorter timescales. However, there are still barriers to the market and the uptake in terms of people using Earth observation data. And I'm showing a picture or a word cloud that really shows some of the terminology that's used. And this can be bewildering for people who have not used Earth observation data before and really are only interested in what the outputs are and what knowledge you can gain. So what's very much happening is those like myself who are specialists in the field are trying to make the data much more easier to use. So rather than necessarily providing people with raw data, it's actually deriving products and information that allow people to then use that knowledge to take decisions themselves. And what I'm going to do today is just show you some example data so that you can get really a feel for what's out there and what's now being used in the broader community. So I'm showing here a series of 3 satellite missions that belong to the Copernicus Sentinel constellation. So this is a constellation that has been launched by Europe and very much funded by Europe. And it's putting up a series of satellite missions to provide data for policy making and also business so that more information can be derived. And the 3 sets of missions I'm showing are Sentinel-1, Sentinel-2, and Sentinel-3. And to give you an idea of the types of data that are now being systematically corrected, and they're also made free to access, are these 3 missions. So Sentinel-1 is a radar constellation. And so at the minute, there are 2 satellites, A and B. Eventually, there will be up to 4 satellites. And the big advantage of radar data is you can both see through clouds and see at night. So there are lots of applications for radar because of these capabilities, but it can also be difficult to handle for those not used to it because it's not what we see with our own eyes. It's not the optical domain, but it's in the microwave. We then have Sentinel-2, which is a high resolution optical missions. Again, 2 already in space with 4 planned for. And these have pixels of the order of 10 meters in size and allow us to see detailed features both on the land and at sea. And then the 3rd set of missions is Sentinel-3. So we now go up to coarser spatial resolution, more like 300 meters to 1 kilometer, but we get a much more quicker global view of what's happening in terms of what we can see optically, but also what's happening in terms of thermal, so heat signatures. And then we also have an altimetry mission, an altimetry instrument on board that satellite that allows us to measure information like height. So it gives you things like wave height, and also wind speed. So I'm going to show you some examples now just to start to really give you this flavor, what's available out there for allow us to support the activity. So this is an example of Sentinel-1, which, as I just said, is the radar missions. And so the data is in its rawest form is in black and white because you're looking at a particular frequency. And the example I'm showing here is the Dutch coast and wind farms off the Dutch coast. And I've zoomed into one of the areas of wind farms to see that they're actually not even just points on this data. This is 10-meter resolution. You can actually see something about the blades of the wind turbines moving as well. You can get much higher resolution than this as well. So if you now go, instead of free to access, you go to commercial data, you're getting to the point with commercial data that you can easily get 5 to 10 meter resolution like this, but you're also getting down to 1 meter resolution. So very much the community who are developing marine applications are now using a blend of commercial and free to access data. In terms of the optical and thermal, I'm showing an example of hurricanes. So on the left, we have a hurricane as seen by the optical bands in Sentinel-3 at the coarser 300 meter resolution. And then on the right in the bright colors is what the thermal view of a hurricane would look like. So you've got the blues and the purples at the eye, where you've got the colder temperatures moving out to warmer temperatures, which are your reds and your yellows. And then in the far right, we have actually a view from Sentinel-2. So now down to the 10 meter resolution, actually you can really start to see inside the eye of the hurricane and really start to understand what the structures are. So for my last example, I'm going to move back to the southwest and Plymouth and some work I've been doing. So in this example, I've been using a combination of the Sentinel-1 and 2 data to do what's called a land cover classification. So this is determining what is on the surface of the earth. So you would classify simply water, green vegetation, forestry, urban, mud flats. And this is really useful because once you've done that classification, then you can apply different analysis tools to different areas. So for example, in the exposed mud flats and along the beaches, we have a current project both running in the UK and overseas, looking at marine plastics and detecting those. And also on this example here, I have dark blue lines, which is shoreline mapping. So here I'm using the satellite data to tell me what is the edge between the land and the water. And that will vary over time, both on short timescales as you have high and low water, but also on longer timescales as you maybe get erosion and changing of the shoreline as well. So I hope this has started to give you a feel for what's available and can be used. As I said at the start, a lot of this data is free to access, although I would say it's not necessarily easy to access at the moment if you're not sure about what you're doing. And so it's often useful to talk to an expert in the first instance to give you guidance. But it does mean that this is now available for many companies and businesses to use. And once you know what you're doing, you can start to derive regular information. So the type of satellites I've shown you will be providing this data every 5 days or less. So thank you very much for your time, and I hope you enjoyed the presentation.
Thank you to Samantha Lavender. Well, our theme today is sustainability in the marine sector and how to reduce the impact of shipping on the planet. Our next guest has seen at close hand how fragile our world is. Jim NcNeill is from Ice Warrior, a project to train people from all walks of life to safely explore the Arctic and help significantly improve our understanding of what's happening there.
Hello, my name's Jim NcNeill. I've been exploring the polar regions for 36 years now, and all you need to know about that is that I've still got all my fingers and toes. So I must be doing something right, or probably more accurately, I've been very lucky. I started life as an environmental scientist, so I have a foot in the door of the environmental science world, and my scientific partners for a project that I'll tell you a tiny bit about in a minute are some of the best in the world, and I don't say things like that lightly. I do have a project called Ice Warrior. We've been going 20 years now, and we've been collecting data for the scientific community with respect to what's happening in the polar regions. The polar regions being so important as far as global change is concerned. In those 20 years, I've trained over 400 ordinary people from all walks of life, all echelons of society, to be polar competent and to go out and do these extraordinary expeditions for the sake of humanity, basically. So we've been working on global change and putting our finger on the pulse of the planet, as it were, for that length of time. And I'm very pleased to say we've managed to be written up in and cited in some very big international scientific magazines, which is fantastic. So the project's called Ice Warrior. It started in 2001, and it does emulate the golden era of exploration where there were no experts and they didn't know how long they were going to go off for in those days. But these days we train them in every single aspect that makes them polar competent. And I reserve the right that if we don't manage to get them to that stage, then we don't take them on these extraordinary expeditions. So that's the background. Having started in the early 80s, the weather conditions and the conditions of the ice, particularly up on the Arctic, which is where I have two bases, one in Svalbard and one in Canada, northern Canada, Resolute Bay, have changed dramatically. And one of the problems associated with that change in weather patterns and climate is that ice breaks up in different areas. Now, the Inuit hand down stories from generation to generation as to where to go to hunt and things like that. And I was trained really by the Inuit of Resolute Bay initially. And those stories have become more and more inaccurate because of climate change. And that has led to more and more incidents of a rescue nature, a search and rescue nature occurring in these regions. That has meant that traveling on sea ice has demanded that we think about it very carefully. And in 2006, I was attempting to get to the northern pole of inaccessibility, which is the very center of the Arctic Ocean, on my own, measuring the snow depth and ice depth and all sorts of other parameters for NASA. And I fell in about 170 nautical miles north of the last landfall of Canada. And it struck me that the devices I was using were wholly inadequate for this sort of travel. So what I have now is born out of part adventure, part citizen science. But actually, I worked for a long time in the fire and rescue service, professionally speaking, and I had a global a global presence, I should say, in terms of working out procedures, protocols, and methods, and indeed equipment to rescue people in these sort of situations. So there is a real need for a new device to travel across the sea ice safely. And I think although it's born out of an adventure, if you like, there is a scientific use for it. There is a military use even, and indeed a rescue. So if you can picture a cross between a hybrid, if you like, between a canoe and a traditional sledge, where you've got runners, a device that you can drag across sea ice. And when you get to open water, and there is more and more of that open water, you can just dump it in and cross, then that is the device I'm talking about. I've called it a Kajak, Qajaq. That word is the Inuktitut word for kayak. And I've been working on iterations of that device for about 10 years now. I am seriously looking for research and development partners to make this device viable. I think it will make traveling on sea ice, or being a scientist on sea ice, I train a lot of scientists during my time as well, much safer, because at the end of the day, it is a cross between something that you can use to travel and put your equipment in, or indeed your monitoring, your instrumentation, your remote monitoring equipment, and something that will keep you alive if the proverbial what's it hits the fan. Currently, the iteration was made by ProDrive, and it's made out of materials that they use for the World Rally cars, just to be very light and very robust. But there is a whole design feature, a whole design spec for it that I've created over the 10 years that I've been thinking about this. I think now is the time, because of weather patterns changing even further, and anyone that goes onto the sea ice, that wants to cross it, that wants to stay still on it, even without the support of a larger vessel or some other device, would benefit from this device. So in terms of sustainability, I think it would sustain life on sea ice. And that's my pitch, really. I've never talked to a machine before, so please excuse my utterances. I'm not too bad with the crowd. But yeah, it's a device for keeping people alive in the very worst of situations and allowing them to travel. It can be parachuted in, where you can't land an aircraft, or even a fixed, or even a rotary aircraft, or either type of aircraft even. And it can be towed by snowmobile into a remote scientific station on the ice, sitting on the ice. It can be filled with instrumentation. So there are lots of different configurations of it. But essentially, you have a hard shell that floats stably on difficult water and terrain, and that's what I've got. I am searching for, as I say, research and development partners, and that's why I'm here talking to you guys now, hoping that you see this as something that we can develop. So, just to reiterate, I think it has an adventurous iteration, a venturous configuration, a search and rescue configuration, a scientific configuration, not only for remote monitoring and instrumentation, but also for keeping those scientists alive if things change, which they rapidly do in these regions. And also a military application as well for the increasing number of foot soldiers that are traveling across sea ice, particularly in the Arctic region at the moment. So that's it. I hope you see the benefits of it. And I'd be delighted to take any questions during the Q&A. Thank you very much indeed.
A reminder that our final Q&A is coming up shortly. Send your questions via the comment box. Our final speaker at Marine Tech Expo 2021 is Phil Culverhouse. Phil is one of the founders of Plankton Analytics Limited and is here to tell us more about the Plankton Imager, a new high-volume shipborne plankton imaging instrument.
Hi, I'm Phil Culverhouse, and I'll be introducing the Plankton Imager, model Pi 10, a new instrument for biological oceanography. There is a clear need to improve automation for biological oceanography. The CTD and other chemical sensors have revolutionized physical oceanography over the last few decades. The 4,000 or so Argo floats situated in our oceans have been providing automatic reports of physical parameters for years, but we still rely on net deployment for plankton ecology. The continuous plankton recorder is the only long-time series sample, but net silk analysis is still manual. There is an urgent need for automation to increase the density of temporal and spatial sampling and the analysis of the plankton in order to better understand our oceans. The Pi 10 is a new instrument designed to address this shortfall. It can be ship or shore-based, and it operates on a pumped water supply to image particles in the length range 180 microns to 20 millimeters, the mesoplankton. It's suitable for ecological survey and aquaculture monitoring. It's proved to be low maintenance. At its heart, the Pi 10 has a color camera of resolution 10 microns and a white light source. It operates at 34 liters per minute, therefore imaging to 10 microns, 2 cubic meters of water an hour. So high throughput for tracking low abundant species. It automatically shares data across a local area network for multi-user processing, currently operating at 500,000 images per hour. The image is encased in an IP67 enclosure that is climate controlled. A slide showing how it operates. Water is pumped through a transparent flow cell, back illuminated with a white light source. The camera captures an RGB line of pixels. Lines of pixels are gathered at high speed and objects extracted. These are saved to disk and shared across the local area network. The instrument is suitable for studying the mesoplankton and other similarly sized particles. For example, radiolaria, copepoda, fish eggs and larvae, detritus, and air bubbles. It can also monitor fish parasitic copepods and the health of a fishery for aquaculture. Here are some slides taken from the Western approaches over the last few years by Sophie Pitois at CFAS on RV Endeavour from a development version of the machine. Notice that delicate organisms are imaged successfully, whereas net sample processing will clump radiolaria and jellies. And more recently, from the Pi 10 in the North Sea, some copepods, their molts, Cnidaria larvae, eggs, and algal cells. These images were obtained at a throughput of 34 liters per minute. The Pi 10 is compact, being 830 by 240 by 140 millimeters. Notice the control panel at the front and flow cell in brass towards the bottom. Connectors are at the top right. The whole package, including mechanical protection in a marine stainless steel frame, shown in yellow on this slide, is 1 meter tall by 675 wide and 260 deep. The IP67 enclosure is highlighted in blue along with the pipework. It can be wall or pedestal mounted for ship operation. Software post-processing adds value to the instrument. Images are GPS and time-stamped and collected in 10-minute folders for convenience. A set of features are extracted for each particle. These are fed into a pre-trained random forest classifier, which sorts the images into classes. We obtained 60 to 90% accuracy on sorting of 42 classes. The data may require a manual validation stage, as is common practice for this type of data. We offer both station-based, that is replacing net sampling, and continuous track analysis. Crucially, the Pi-10 can take the same water feed as the ship's physical instrumentation and flow meter. So the classifier needs training. But once trained, it can be applied to samples from the same geographical region. Images are shared in real time, making for concurrent report analysis on board ship. Because each image is GPS time-stamped, spreadsheet reports holding this data and an object's length, width, area for conversion into biomass estimates, and class can be available within minutes of completing a station. The software is currently supported under Win 10, Ubuntu, and Mac. Here is a video showing the flow cell component. We're pumping 0.8mm calibration beads through the system. They appear as white streaks in the video. We're running at 2 cubic meters per hour. Our Pi-10 instrument offers a cost-effective replacement for net-based ecological surveys. A recent study by Sophie Pitois at CFAS in Lowestoft revealed that existing ring net surveys cost them £7,400 to process 50 samples, whereas the Pi-10 system only costs £1,500. Also, nets cannot be used for continuous track operation, and the Pi-10 can image tracks that are too fragile for net sampling. As I said earlier, radial area and jellies, for example. I'll skip through these slides quickly, but they show the processing stream for image data. Station-based analysis can specify the number of minutes on station and the number of specimens to randomly subsample from that station dataset. Images are extracted, analysed and sorted. Validation and report generation follows. In the next slide, you can see images are stored within the station folder structure and the processing trail is logged. Each specimen has a spreadsheet entry with its time of sample, GPS location, and class, as well as length, width, and area. Finally, the biota at each station is also summarised. For example, on this slide, Prime 111 had 2 amphipoda and 54 copepoda in the autumn Peltic survey 2020. Continuous track analysis is novel and allows for temporal subsampling. Our PhD student, James Scott, produced these results for the recent Autumn Western Approaches survey in 2020. This slide shows plots for copepods and the developmental stage nuclei and radial area by satellite-defined grid squares. The ship's track is also shown. Abundance is given by colour density. 16 million images were obtained from those cruise tracks overlapping the grid squares. Temporal subsampling at 10:1 required 1.6 million images to be processed, classified and validated. The plots revealed 28,473 copepods, 5,496 nuclei, and 2,752 radial area were coincident at the same grid cells. James is working on linking satellite and flow cytometer data with these cruise track ground truths. In addition to routine scientific ecological cruises, the Pi-10 could be used on ships of opportunity. This would obviously need data processing hubs to be set up, but it could increase by many orders of magnitude the availability of biological plankton distributions for modelling and science. Imagine trying to predict the weather over the UK by taking temperature, humidity, and wind direction once a day at 100 locations. It's not possible. This is the reality of current mesoplankton models of our oceans. Yet the mesoplankton make up a significant contribution to the carbon cycle of our planet. This in turn will drive the production of better spatial and temporal oceanographic models. Fisheries and aquaculture can also use this instrument for continuous monitoring of the health of the fishery and early warning of parasitic copepod blooms. If you're interested in more details, please contact me, Phil Culverhouse. This slide shows the current set of publications that demonstrate the Pi10 is equivalent to net-based sampling of the mesoplankton. And finally, many, many thanks to Sophie Pittois and her CFAS team for their time, support, ship time and enthusiasm. Also to James Scott, our PhD student, and Jill Mallin at UEA. And finally, to Hayden and Navina for their invaluable expert plankton taxonomy knowledge, essential in this modern age. Thank you.
And if you have any questions for our guest speakers in this session, you can post them now in the comments section of the YouTube channel. And I'm delighted to say that Phil, Sam, and Jim join us live to answer your questions. And Jim, if I could start with you in the studio with me. On your explorations of the Arctic over the last, well, 3 decades or more, what changes have you seen? What's been the most noticeable change in the climate there?
Massive. I mean, weather patterns have disintegrated. You used to be able to detect or at least predict what the weather used to be able to be doing. When you went out in March, for example, the sea ice would be flat and straight and the wind would be coming from a certain direction, and that has all gone to bits, basically. Yeah. So the changes has been dramatic. The sea ice has disintegrated. We've lost 75% of sea ice in the last 40 years, which is just over the amount of time I've been doing it. But when you go up there now, the topography of the islands even has changed dramatically because of climate change. And of course the species have too.
And what risks does that pose for those who want to explore for scientific purposes? It's obviously, as you pointed out in your presentation, increasing the risks when people go there. What difference is it making?
Well, the sea ice can break up at any time in any way, is the truth of it. And when it breaks up, it jostles about, it smashes into another bit of sea ice, which forms a ridge on the top and a keel underneath, both of which are floating about and affected by the weather patterns. And so once that starts happening, and we don't really understand how that works either, which is what we're working on, so ice deformation and formation is critical, then the whole thing becomes very much a dangerous place to be. And so the whole idea of the Kajak is to make it safer.
Yeah, and we'll talk about that in a moment. I'm just wondering how you go about training the people that you send there, and you've sent several hundred people there or helped them to prepare to go there. How do you set about preparing them when the atmosphere there, when the climate is changing so much and there are so many more variables to factor in now?
Yeah, well, you have to go through the whole of the training process absolutely thoroughly. And so we start normally with novices, or even if they've got experience, we assume they've got no experience, and we train them on Dartmoor to begin with, actually. So they all have the core skills, and then we take them to our 2 bases, one in northern Canada and one in Svalbard, and train them in every single aspect that makes them competent and relatively safe. It's inherently an unsafe environment, but we make it as safe as possible, and our mitigation or our control factor in the risk is the training itself. So, yeah.
Let's bring Sam in at this point, because I just wonder, Sam, how much you're observing from space what's changing in the climate in the area of the globe that Jim was just talking about. What are you observing from space about what's happening in the Arctic?
So we're definitely seeing what is being experienced on the ground, and the big advantage of the satellites is that they're global in their view, and they go back over 20 or more years. So we've got satellites in space focused on all aspects of the climate, and certainly the Arctic is one of the big areas of interest at the minute. And we can track the changes of the thickness and the distribution of the sea ice and how it varies from year to year. And that's a really useful data set for including in models to try and predict what's going to happen in the future.
And looking at oceans in particular, how can observations from space help to inform those of us on the ground about our actions and what we're all doing to affect the oceans?
Yeah, I think most people, especially if they don't live near an ocean, don't really understand it and think of it as just a blue water mass. But as Phil was talking about, it's really full of living organisms. And the actual plants in the ocean, the phytoplankton, absorb the carbon dioxide we breathe. And without them, there wouldn't be enough oxygen for us to breathe. And so the ocean is actually really critical for human beings in terms of both oxygen and as a food source. And obviously things like sea level rise will affect our homes as well. And we have satellite missions focused on each of those aspects. And so we're monitoring over time how the oceans are changing so that we can try and understand what will happen in the future as climate change occurs.
Phil, let me bring you in at this point. I mean, Sam was explaining there how the images from space can help inform all of us on what our actions are doing to the ocean. In terms of the images that Pi 10 is getting, how will that help inform the debate?
Well, some of the last slides I showed demonstrated some very recent work by James Scott, our PhD student at UEA, working with Sophie and CFAS, to take the satellite-generated grid squares, which have, as Sam said, all of the phytoplankton, so the chlorophyll, the green plants, producing the oxygen. And we overlay on that the distributions of the early parts of the carnivore food chain, the copepods, which eat the algae, and they in turn are eaten by the fishes. And this is the first time really we've been able to do this following an idiosyncratic ship's track and zigzagging across, as you saw, extracting information as we go. This is, I think, the future of how to enrich our models of what's going on in the oceans.
Let's talk about it in more detail. I mean, how easy is it, for instance, to install?
It's really easy to install. You saw on the picture there's an inlet and an outlet for the water on the brass flow cell. We've got a stainless steel housing that protects it from mechanical disruption by other activities going on board ship. It's a plug and play, and about every 2 weeks, you need to turn the ship's pump off, or at least turn the valve off, take one of the hoses out and clean the optical elements of the flow cell, and then put it all back again and run it. And we've been doing this for 2 years now without any major issues.
One of the themes of this event has been sustainability and energy consumption. What is the energy consumption of Pi 10?
Well, the camera system is working at pretty high speed. It's one of the fastest cameras you can buy. And it's consuming, the whole of that box, the Pi 10 box, is consuming around about 40 watts of energy. The problem, I have to say, is not the generation of the pictures, because that's really low cost and that could go on by itself, but is the processing of the pictures in the workstation that connects to the Pi 10. And that uses, at the moment, is using either a multi processor array or a GPU, and consumes about 500 watts. So, but those energy budgets are going to drop over time, and also the performance of the machines is going to improve.
I've got more questions for you in a moment, Phil. Sorry, finish what you were going to say.
No. Well, just that it can, we can't put it onto underwater systems at the moment, but in the future.
More questions for you in a moment. I want to come back to Jim in the studio. And you mentioned Kajak a moment ago. At what stage of development are you at with it?
Well, we've got a prototype, and we've got two prototypes to really cut apart, so the 3 in total. But I really like to go back to square one because it was developed 10 years ago and look at materials. I think we've got the best material, but I'd like to revisit that with the partners that are going to come on board and develop this thing, and also look at energy harvesting, energy creation as we go along. And communications is a vital part as well. There's no point in dropping something to someone in trouble if they can't communicate with you and tell them how they're faring and what's going on. So there's lots of technology that can be put in these devices for the betterment of the person in trouble, basically.
The motivation has come from your exploration of the Arctic, but would there be wider applications, wider uses for it once it's developed?
Yes, absolutely. I mean, I've been talking to the RNLI about a beach version that can be flown in by drone. I mean, they're looking at sustainability in the future, and I mean that's amazing, really, when you think about it. And of course, there's flash flooding that is increasing every year, with the storm systems that we experience.
In terms of the RNLI deployment, that would be a survival kit pod, if you like, getting to that person without putting a lifesaver in immediate danger.
That's right, or people or the expense of getting a very heavy vehicle to that area. And of course we are looking at propulsion as well, because electric propulsion for it. So it's a first aid, if you like, in terms of the person that's in trouble. It wouldn't be a life-saving device full stop, but a first aid thing that you could deploy rapidly and with minimal amount of effort and energy expense.
And in terms of its stability, I mean, if once it's in the water and deployed, it remains stable.
Well, it is amazing. I mean, it was designed so you can drag it across sea ice. So it's a double hull with a runner system, which on sea, I don't know anything about this, and I'm sure there are some experts out there, but it seems to be, I can stand up in it in the middle of Plymouth Bay there, so with ease. So it's amazingly stable, and once you start to tip it in one direction, it sort of self-rights itself in a way. So
I just want to take you back to that incident in 2006, which focused your mind on developing this when you went through the ice.
Oh, yeah.
What exactly happened, and how did you get out of it?
Well, I was travelling towards the northern pole of inaccessibility and measuring things for NASA, as I said. I fell through the ice. When these pans of ice pull apart, they cause a shear zone. I was trying to get across the shear zone. I had made the mistake of having a wonderful day. I knew a storm system was coming. I should have stayed put where I was, but instead I wanted to get across this next bridge too far, as it were, and I fell through, and then I managed to drag myself out with much difficulty, but I got on to a stable area there, and it was there I thought I really must develop this Kajak, because that would have been much easier to cross such terrain, and it's a device you can take off the ice and deliberately plonk in the water and paddle for as much as you like. So a game changer in terms of getting across.
Indeed. So 10 years on, more than 10 years on, but you're now at the point where you need further investment to get this sort of mass produced.
That's right. Yeah, and it's an automatic monitoring device. It's wonderful to have the satellites, but they need calibrating. So we're a ground truthing, if I could say it, device for the satellites. Which is very helpful. And we do have this lack of understanding about the physics of how that ice deforms and forms. And that's particularly pertinent to the accuracy of saying how long that ice is going to be up there. And of course,
so its development feeds into our scientific understanding of what's going on, because
absolutely.
it will enable more scientists to safely go there.
Exactly. I started life as an environmental scientist, so that's where it's all born out of my heart, really. Yeah.
Let's bring Sam back in at this point. And you talked earlier on, Sam, about the satellite observations helping us understand what's happening with the Arctic. What's it telling us about things like plastic pollution, which is another theme that we've been looking at today, and the things that are going on pollution-wise in our oceans?
So we're actually specifically collecting satellite data at high resolution, the Sentinel-2 mission I talked about, over the open ocean, where it wouldn't normally be collecting data, to look for floating plastic debris. And then the project we're working on in Indonesia, we're actually trying to map the pollution along the rivers where it gets into the waterways. And then there is a French company, CLS, who models then where it goes. And then we again look for where it arrives back on the beaches. And really, it's all about understanding the pathway. So where is it originating from? Where does it end up? And then that helps people in order to put in place mitigation techniques to try and prevent the plastic getting into the oceans. Or if it does, to know where it's going and hence where you need to focus your cleanup efforts.
And you talked in your presentation about the accessibility of that data, and much of it is freely accessible, perhaps not easy for some people to find or to analyse. What work is being done to make sure that that data is as accessible as it can be?
So as well as Copernicus itself launching satellites, they are also running services that make data available that has been processed from those satellites. And then ourselves, as a company, we do the same. So we will link up with customers who are interested in monitoring something environmentally. And they will say to us, can we get information from satellites that will help us do that? And then we'll go through a process of developing a product for them that then uses that data to give them that information. And there's a sort of almost an endless array of possibilities. And you really need the customers to come to you with their ideas, and then you can discuss what is and isn't possible at the moment, or might be in a couple of years' time.
Another application, I guess, is looking at how our coast is changing and coastal erosion. What are you getting from satellite images, and what are those images telling you about coastal erosion?
So we do now have global data sets derived from satellites that look over tens of years to tell you how coastlines have changed around the world. And we're also doing some work in terms of how to more quickly map coastal change as well. So when you get a landslip that we have been having around the southwest, when you have heavy rain and you lose part of the coast, detecting that quickly and then allowing that to be surveyed and understand what action to take.
It was interesting to see your example of I think it was the wind farm off the Netherlands, and the resolution was such, the detail was such that you could even see what the individual turbines were doing. I mean, is that technology able to be enhanced further once it's launched? Is that it, or can you further enhance the onboard equipment so that those images become even better?
You can do some enhancement with the data on the ground, but at the minute, once satellites are launched, they're really up there and not easily accessible by astronauts. So what we're actually seeing is different satellites launched for different applications. So we tend to have bigger satellites, which are scientific missions and that are more accurate. And then you have the commercial companies, although space agencies are doing the same, now launching what are called CubeSats. And so these are very small satellites, and you can launch large constellations of them and get more frequent and high resolution coverage as well with those. And it's the combination of the two that's really starting to move things forward now. You've got companies promising that you can image everywhere on the Earth every day.
Extraordinary. Well, on the subject of resolution, I wanted to bring Phil back in at this point, because you gave some very clear examples there of some of the amazing resolution that Pi 10 can give. What is the actual resolution of the Pi 10?
10 micrometers, which is 0.01 of a millimeter. So I suppose that's less than the width of a human hair. But the plankton are microscopic. In fact, they go from microscopic through to macroscopic. And the algae are generally up to about 100 microns. So we can image the bigger algae, some of which can reach a millimeter, in fact, actually. And then most of the zooplankton, the little critters that eat everything. But we have designed a system that images everything in the water. So as you pump the water through, we guarantee every part of that water that's being pumped through is imaged to that 10 microns. And then, as you were saying earlier about the energy budget, we have a big computer behind, which is extracting all of the particles from the water and then feeding them into a classifier to sort them so they can be useful for biologists and ecologists.
You talked about the water pumping through, and will Pi 10 work at a lower water pump rate?
Yes, yeah, you can turn it down. It's probably a bit of overkill. We are working on a device that doesn't pump quite as much as that can be put on board an inflatable and taken out to sea as part of marine ecology surveys. But this is designed to replace net sampling. And so it has to really pump 2 cubic meters of water an hour to become the equivalent to net sampling.
People will be familiar with images from space of algal bloom forming. We've seen it often happen off the southwest coast in certain weather conditions. Yes. How is Pi 10 helping to inform what's happening with developments of things like algal blooms?
Well, that actually joins 2 parts of this afternoon's presentations together, because what Sam is doing is analysing or one of the spectral outputs, I guess, would be analysing the locations and densities of algal blooms. What we're interested in doing is seeing how those algal blooms are eaten by the local predators, so that we can look at the dynamics of the food web at that location. It will inform fish stocks, for example, so you can be predictive about where the fish stocks are going to be, and also over a period of time see any anthropogenic impact on fish stocks due to impact on smaller organisms down the food chain.
Jim was describing the changes in climate and the effect it's having in the Arctic. Are you seeing through Pi 10 changes in what plankton are doing as a result of climate change?
Yeah, we haven't been doing a long enough time series, or probably it's not really called a time series at all. CFAS have been deploying this in the Celtic Sea and Western approaches, and we've only been doing that really for 3 or 4 years in any consistent way. I think the next decade will be interesting for the Pi 10 and instruments like it, because we will be able to construct a much deeper, denser map of distributions of zooplankton across the oceans, which we're desperately lacking at the moment.
And Sam, in your presentation, you demonstrated how that from space we can also see the temperature changes going on in the ocean. What are the observations from space telling us about what's happening to sea temperatures?
So we are seeing variations in sea temperature, and they get driven by decadal time series. So you'll hear of things like El Nino. So you see temperatures go up and down due to that. But there's also, underneath that, there is changes due to climate change as well, which is overall doing an increase. But and some of the difficulties is that often climate modelling quotes one number, whereas actually things vary a lot across the globe. And one of the big issues that's being researched is not necessarily temperature its own, but also by having carbon dioxide absorbed in the oceans, you get increased acidity. And that causes a lot of problems for marine mammals and the smaller ones with shells as well. So it's really lots of combined factors that are really impacting what's growing in the ocean rather than single factors alone.
It's some interesting things going on with space at the moment. There's a sort of renewed interest in space, and of course there's a spaceport being considered in Cornwall as well. Tell us a little bit about the advances going on in terms of launching more things into space.
So traditionally, your launching into space would be from your conventional rockets that most people think of with vertical liftoff. But increasingly, there's an interest, especially now we have these much smaller satellites, something like the size of a shoebox or smaller, is actually you launch them more off the equivalent of planes. Or then some of them are actually taken up to the space station and basically thrown out the door as well as another way of launching them. So there's a lot of interesting things going on, but there's equally concern because as we launch more of these small satellites, there's more debris in space, and that could cause problems in its own right. And certainly astronomers are not necessarily happy when you get the sun glinting off satellites and affecting their observations.
I was just wondering how space development and satellite development has changed how you explore places like the Arctic over the near 40 years you've been doing it. How has technology changed the way you approach those trips?
Well, it's made it much safer. We can now look at sea ice in front of us, not on a micro scale, but certainly on a macro scale, and so that helps an enormous amount. But also in communications. I mean, we do a check call over a satellite telephone that when I first started using, you had to almost wind it up, and it was a great big brick, and it rarely worked very well, and you cut off. But these days, it's immensely efficient. And in fact, talking of the satellite network that's going up there, one of our latest sponsors has offered their network of communications across the globe, which is 500 megabytes per second anywhere on the globe, which of course is a complete game changer in terms of getting data, shoving it up to the cloud, whatever the cloud is, and
so observations being made by scientists on the ground can instantly be shared across the globe. Yeah,
particularly things like the Plankton analyzer and stuff like that. I would imagine, I don't know, I'm probably talking out of turn here, but where there's a need to mass analyse data, it doesn't necessarily have to be done in situ. It can be done remotely.
Well, Phil, let's bring you back in on that. I mean, is that an application for Pi 10? It can be used in those sort of very inaccessible, inhospitable places?
Well, I suppose it could be. Our system is designed, this specific system, the Pi 10 was designed for ships of opportunity, really. So marine institution ships and to banana boats, Maersk shipping container lines. Just put one on board and then collect the data on a hard drive and send the hard drive when you get into port. It's certainly attractive to think of sending the data back home as you are steaming along in the middle of the Pacific Ocean. I'm not sure how that would work. I have a feeling that if we did this on, say, 4,000 ships of opportunity, we'd probably saturate the satellite system. But who knows? These things are all possible, and the idea of processing in the cloud becomes processing up in the satellite, doesn't it?
And Jim, just coming back to the people you've helped to prepare to go and explore the Arctic, how much do you hear back from them? What knowledge do you gain back from those people who then go off on their own adventure?
Well, hugely, really. We have our own scientist who puts these portfolios of scientific data gathering together for us. And, our own scientific partners are some of the best in the world, and I don't say that lightly. We just joined forces with the local Marine Biology Association, for example. But because there's a lot more to an ocean that's frozen, particularly as it becomes unfrozen. There's an awful lot that we're doing.
Okay. Final thoughts then. Where are we at with CAJAC? What's the next step for you in that project?
To get a developer, a research and develop department to look at everything we've done so far and get it into the right shape and form that we can come up with these iterations, and we know the new technologies that we're going to be using, how we're going to be using them, and configure them properly.
Okay, and Phil, the future for Pi 10, what are the next few years going to be like for Pi 10?
Well, selling into ships of opportunity, as I suggested, I think we need to massively improve the density of sampling of the mesoplankton so we can understand what's happening between algae and the fish stocks.
And Sam, how do you see imaging from space further enhancing our understanding of what's happening down here on Earth and in our oceans?
And hopefully it'll become like satellite positioning and satellite timing. People will no longer think of it as something special. It will be something that's used by everyone all the time.
Yeah, good.
Well, some very interesting developments which we will all keep an eye on very closely over the months and years ahead. Phil Culverhouse, Sam Lavender and Jim NcNeill here in the studio. Thank you, all of you, for joining us and sharing your thoughts and having an input in Marine Tech Expo 2021. Now, if you've been with us throughout the Expo, you'll have heard us talk about the Smart Sound, this incredible area of sea off Plymouth, which has lots and lots of instruments to measure for testing of maritime equipment and some of the technology we've been hearing about. We're about to see a demonstration of some of the technology there and the evolution of electric boats as well.
Well, today we're putting up our remote DTC node up on top of the Ramehead Coastwatch station. This will enable us to do remote operations from the marine station, backhauling data from Coxside up to here using the 4G system. We can run the vessel, of course, on the 4G network, which means we can obviously bypass having our own communication nodes like this. But currently the 4G system has some quite limited range. And it's very variable. Sometimes we can use it to 2.5k south of Ramehead. Sometimes it's viable up to sort of 9 to 10k south of Ramehead. And having that lack of reliability just isn't really acceptable with remote vessel operations. So that's why it's good to have our own system that we can use. And of course then this 4G system is there as a fallback. The shoreside control station setup. You can see there are various components to this. First of all, we have the helm. That's this device here. That's quite similar to a standard remote control unit. You can use that to drive the boat manually. Here we have the user interface, which is where we do our mission planning. We can control all aspects of the vessel, monitor its performance, monitor all the key systems, and turn various things on and off. And this here is the payload computer, which is linking into the Norbit multi-beam control system that's over there in the payload bay. We've got 4 different ways of communicating the vessel. First way is to plug in via a shore cable, which is quite useful for doing certain high-level diagnostics. We have 3 different wireless communication systems for the boat. The first is this one here. This is the DTC mesh radio network. This is a military-grade communication system and can give us between 6 and 30 kilometers range, depending on the elevation of the base station. We then have a Wi-Fi system here, these 2 white antennas at the top, that can give us a kilometer range. And where we have a 4G cell net communication, these 2 white antennas at the bottom that can obviously give us control of the boat anywhere within a cell phone coverage area. The way this works, if we lose one, it will seamlessly switch to another one, which gives us lots of redundancy, lots of backup, which is quite a nice thing to have if you have quite a big, expensive boat driving around in the sea. So this vessel has several different systems for situational awareness. The first and foremost is AIS, that's Automated Identification System. That's where all vessels transmit their name and their direction and their speed via VHF antenna at the back there, and that gives us a readout on our chart, which you can't see at the moment because we don't have a GPS fix. But that tells us all the other vessels in the vicinity and where we are relative to them and their speed and direction. We then also have a radar, which is very useful in any sort of low light conditions. And the great thing about this is the radar is overlaid on the chart, so we can see a correlation between the AOS and the radar. We then, of course, have cameras. Now, this is a later edition of this boat. It has 360-degree cameras, so we have cameras forward and aft, port and starboard, and we also have an IR, infrared, night vision camera as well. So currently I can see the forward part of the workshop. If I can switch to the port view, there we are, we can see us there. So eventually the aspiration is to have these on screens all around us to give you a kind of full feeling as though you're sat on the vessel, actually driving it yourself. So this here is the payload computer. All of the actual software for running the mission hardware, so in this case the multi-beam, is actually in situ on the vessel. And all we're doing here is we are team viewing in using a remote desktop function into the computer on the vessel, and then controlling the software as though we were sat on board.
Hi, my name's Conrad Humphreys and I'm the founder of the Bounty Project. It's a project we set up after the recreation of Bligh's voyage for Channel 4, where we took a small, tiny little open boat 4,000 miles across the South Pacific and recreated that incredible voyage after the mutiny on the Bounty. The Bounty Project was set up in 2017 and the idea was to really focus on creating a living history project for young people to really experience the incredible history and maritime history around Plymouth Sound. And we've taken the boat over to other parts of the country as well, but there's a real rich appetite here to combine the sort of educational opportunities with some of the historical places. And in 2018 we decided it was a good idea to fit an electric motor and electrify Bounty's End, the actual boat. And that's in part so we could continue to use her for further afield. We could get younger kids involved, and of course they don't have to row the boat. They can use the electric motor if necessary to get around. But the real advantage of that is it means that we've got this quiet, clean propulsion boat modelled on something that's 250 years old. And it's a great teaching point for young people when they're exploring this boat, exploring the place, and of course, seeing this new technology that's in place. So the electric motor that we installed is a Lynch motor from a company based in Honiton. The batteries, we were a little undecided at the time about whether we'd go with lithium or a standard AGM. In the end, we went for an AGM 160 amp hour Rolls battery, which is a decent battery. Pretty heavy, and that gives us some additional ballast in the boat, which was needed, so that's a good thing. The other unique thing about the motor is that when the boat is sailing, it'll actually continue to spin the prop and recharge the batteries, and I wanted something that would have some regeneration capability, so that if we're potentially on another longer voyage, when we're sailing, we could keep the batteries topped up. All of these make just great sort of teaching points for the young people as we start to explore the opportunities with regenerative blue energy. So where I see the future of this is a combination of things. I mean, first of all, we're sat here in Mountbatten, a situation that's about to go through a whole sort of revelation of changes here. One of the things that we're going to see quite soon is the Smart Sound project and the new Vodafone 5G network in Plymouth Sound, and we want to combine the use of the historical storytelling with the 5G network, so we can actually stream some of these adventures live across the country and across to schools around the world. The other critical part of this is the electrification of the water. And that is going to be something that, similar to the car industry, is going to happen very quickly if we're going to meet our targets for 2030. What it means for somewhere like Mountbatten is what I call the sort of micro energy revelation or revolution. It's where we take these incredibly innovative electrical products like the e-propulsion sort of 1 kilowatt motor, which we've seen so successfully over the last few years go onto the back of dinghies, phasing out normal sort of petrol engines, and that technology is only going to increase and more prevalent on the boats around us. And the micro is also things like kayaks and small little boats that ordinarily wouldn't have any benefit from electrical power. We're now seeing smaller and smaller motors fitted to these things. They've got regenerative capability, so actually when you're paddling, you're charging the battery, and it's perfect because it gets you home from the pub afterwards. And that's sort of what I call the sort of blue energy revolution is going to be something that over the next 3 to 5 years is absolutely huge in the UK across the South Coast. So one of the immediate things we've done here, because the challenge for the industry, the challenge for all of us, is the fast charging. And whilst there are companies ready to meet the demand, we haven't quite got the infrastructure in place, but that will happen pretty quickly. In the meantime, we've set up a 2 kilowatt energy system on the top of our container, producing enough energy for me to be able to recharge the batteries on Bounty's End, for me to power a small office, for me to power all of the electrical components and modems for us to connect to the 5G network. And we're doing it all off grid. And that means that we can run our team, our activities with the Bounty project without burning any fossil fuels, which is tremendous.
Exocean collects data for clients, ranging from mapping the seabed to monitoring the environment. However, they do this differently. Rather than use a conventional survey vessel with a crew on board, Exocean has developed an uncrewed platform known as a USV. The USV can operate over the horizon without the need for a mothership or line of sight of land. It also allows Exocean to bring the surveyor online in real time to monitor the data from anywhere in the world. So why use USVs? Exocean's pioneering USV platform offers significant benefits, including safety with operators remaining on shore, efficiency with 24/7 operations, environmental with ultra-low emissions. Exocean's USVs emit 1,000 times less carbon than traditional survey vessels. Together, this leads to significant economic savings. To date, Exocean has delivered over 100 offshore missions, regularly transiting, unaccompanied, hundreds of kilometres from shore for clients across multiple industries, including oil and gas, offshore wind, and government agencies. The company currently employs over 100 people across Ireland, the UK, and North America, and has recently begun operations in Asia. Let's take a closer look. Exocean and Sonodyne International Limited have successfully completed a multiple live seabed-to-shore data harvesting mission using USV, most recently for AS Norske Shell as part of a seabed monitoring campaign at the Ormen Langefield offshore Norway. The project, which was completed without a single person having to travel offshore or from their home office, was achieved with significantly less emissions, health and safety risk and cost than could be done with a crewed vessel. By using an Exocean XO450 USV to harvest data from an array of Sonodyne's long-endurance fetch pressure monitoring transponders, an estimated 5.4 tonnes of CO2 per day was prevented from being emitted into the atmosphere had a traditional crewed vessel been used. Exocean's USVs have a negligible carbon footprint, and all other emissions were offset, resulting in a fully carbon neutral operation. The USV transited a total of 300 kilometres from Kristiansund out to the Ormen Langefield and back over just 3 days. All the data was securely transmitted to the client onshore before the USV returned. The Fetch PMTs were deployed in 800 to 1,100 metre water depth at the Ormen Langefield to support a long-term seabed monitoring campaign. The Fetch PMTs accurately collect pressure, temperature and inclination data at the sea floor at pre-programmed intervals. Using this data, any vertical displacement of the seabed can be calculated. The collected data will help Norske Shell to proactively inform its reservoir management strategy. Sonodyne's long-life Fetch PMTs incorporate a high-speed acoustic modem, which allows stored data to be extracted at any time wirelessly through the water on demand. On this mission, the XO450 was equipped with a compatible Sonodyne Mini Ranger 2 acoustic transceiver attached beneath its hull. This transceiver was installed and integrated by Sonodyne engineers at their facility in Plymouth and tested in the Smart Sound waters. The proximity of shoreside engineering facilities, suitable berthing and open water testing sites made this process very efficient. For more information on how Exocean and Sonodyne International can support your future uncrewed missions, visit our websites exocean.com and sonodyne.com.
Hydroserve is an innovative designer, builder and operator of unmanned surface vehicles. Today we're accessing the Smart Sound facilities to carry out a proof of concept for force multiplier operations using 2 USVs from a manned support vessel. So USV Dart is a Reeve 16. It's a 1.6 metre USV, fully electric, designed for operation in inland waterways and sort of nearshore coastal work sites. This is the smaller of our USV systems, and it's deployed and recovered from a support vessel.
We trialled a multi-USV deployment. It's the first time that we've done it at HydroServe, and we're trialling it because we wanted to be able to see how we can use multiple platforms from one survey vessel like we have on Falcon Spirit. So we had USV Dart running survey lines in the shallower sections near to the breakwater. We had Cetus working more south of that, getting some slightly deeper sections, and then we had Falcon Spirit working around the two survey boxes.
And having this equipment, gives you a real experience, and especially in this industry, experience is massive. And I noticed that people looking at my CV always focused on what experience I had gained and what equipment I'd previously used. I think the USVs in particular are an up-and-coming kind of technology, especially in the surveying area. They're low impact and they're also lower cost. And so I feel like this is the direction that a lot of companies are going to start to veer towards in the near future.
So staff and students at the University of Plymouth are really excited in celebrating a highly successful first summer of working with the unmanned surface vessel Cetus, which has been supported by the MBTC. And we've worked with a range of really interesting and innovative local businesses in doing that.
We've been operating with HydroServe's USV Dart here. It's a Reeve 16, 1.6 metre vessel. We've deployed it safely and recovered it from the support vessel here, Falcon Spirit. Operation's gone really well, and we've collected a lot of survey data actually. We've been very impressed.
For the university, this is a great opportunity to collaborate with industry at the cutting edge of innovation, and also it provides a fantastic opportunity for our current and recent graduates to get experience of working right at that cutting edge of marine science.
Well, the story of eVoyager is dates about, we started about 4 years ago. The concept was born about 4 years ago. At Plymouth Boat Trips, we operate several ferry services out of Plymouth, Cremel Ferry, the Royal William, Barbican to Royal William, Mount Edgecombe Ferry, various harbour cruises, fishing trips, along with the iconic Cremel Ferry service linking Devon and Cornwall across the River Tamar. One of the UK's oldest established ferry routes. In fact, I'm going to claim it is the oldest. So we run the Cremel Ferry. We operate the contract for Plymouth City Council. So I'm deal quite a lot with Plymouth City Council, and the contracts manager for the Cremel Ferry, Mark Porter. And we were having a contract update meeting here at the boathouse. And we were just sort of talking about, this electric vibe, and is it going to happen? And we both got excited about it. And it turned out then that there's a chap that Mark knew called Didier Cavreau, who was doing his masters at Plymouth University in electric marine propulsion. So we got him down the next day in the boathouse over several cups of tea. Drew his knowledge in. He was really a great help. Drew in his knowledge, and myself and Mark, and we thought, I tell you what, we're going to push this ahead. Let's go for it. There were people just sort of starting to develop this technology for the marine sector. Original plan was to convert one of our bigger ferries. We operate 8 passenger boats ranging from a little 12-seaters, 28-seaters, 64-seaters, 128, 143, 191, 241. I was going to try and convert one of our bigger ferries, the 100-seaters. Decided, that, okay, let's not take such a big step. Let's start and prove the concept with one of our smaller boats, and it was called the Mermaid. Only a little 21-foot Saltram, built locally, Saltram 21, cracking hull, called the Mermaid. So that was the boat we chose. Myself and my brother, we operate Plymouth Boat Trips and also Voyager boatyard, which is based in Southdown in Cornwall. Okay, so we decided, right, Mermaid's the boat. We had the technology. We you know, wasn't proven or complete, so we said, let's do it. So the Mermaid was sent to Voyager Boatyard. You know, we chugged over there with the diesel engine, smoke, you know, coming out, typical diesel style, oil in the bilge, although we try and keep it clean. And really, it was amazing. Diesel engine was lifted out, a four-cylinder Ford. You know, I'm a big fan of diesels. You know, this wonderful lump coming out, diesel out, gearbox out. The whole boat was refitted to a really high standard, you know, right the way through. And we then worked with several companies out of Devon. So we brought together Plymouth University, Expo University, that did a lot of the technical help. You know, they were fantastic. EV Parts out of Ilfracombe. Okay, they are the pioneers actually of the electric propulsion system and battery supplier. Really good guys. And Plymouth City Council as well, because you know, one of the things we're building an electric boat, electric ferry. Yeah, that's one part of the deal. The other part of the deal is you need to charge it up. So where that ferry operates, you need charging facilities. So Plymouth City Council throughout have been absolutely fantastic. And you can see one of our UK's first, you can see the little E-Voyager here. There she is alongside the famous Barbican landing stage. And just up to the left is a purpose-built electrical charging system. Out with the diesel, in with the electric motor, lithium-ion batteries, which was out of Nissan Leaf cars. They were crashed. So we ended up buying Nissan Leafs, took out the batteries because they're awesome. And EV have coupled those together, giving us a really excellent power, which drives the what was the Mermaid, now the E-Voyager, really, really well for about 6 to 7 hours. So the launch day was really, really exciting. So there was a lot of people there. We had Councillor Mark Coker, we had Cheryl Murray, the local Cornish MP, Member of Parliament. She was there to crack the bottle of wine on the bow. That was awesome. And we had a personal letter from Grant Chaps, the Transport Minister. You know, dear Mr. Squire, Voyager Boatyard, congratulations, good luck. So it launched, and you know what? It worked fantastically. There was BBC News were there, ITV News were there, various newspapers. It was a big thing and is a big thing. We launched the UK's first seagoing electric ferry, you know, which is a real achievement. And so yeah, sea trials, you know, were undertaken. We weren't allowed to operate this boat straight away carrying passengers. We needed a 3-month proof of concept to make sure it was safe, worked well, and quite fair enough. And to be honest, I'm over the moon with the boat. Big fan of, you know, and trusted technology, being the diesels. You know, if something goes wrong, you know, we know how to fix it and stuff. And I was a little bit skeptical. Would the E-Voyager stand up to the rigours of commercial operation? Not just driving around, you know, like on a pleasure basis. When you're working ferries, you're in, out, stop, start, round you go, bump, bump, bump. You know, it works them hard. And it's been fantastic. It's done the job. It looks great, but it actually works, which is the key. The passengers love the E-Voyager. What, you know, I didn't consider fully was how much from the customer experience, how much the customer experience goes up. Diesel engine, you know, you've got fumes coming out, and you know, sometimes you can smell that diesel on ferries. You can certainly feel them with the vibration. The E-Voyager is unique. It's silent. You are travelling through the water, a bit like sailing. I haven't done a huge amount of sailing, but you know, there is no noise to the motors, so the customers can hear the waves, they can hear the seagulls, and you know, there's the boat is not vibrating. It's an awesome customer experience. The passengers love it. The future for Plymouth boat trips, having improved the concept, pioneered the systems, developed the technology at Voyager Boatyard. The future for Plymouth boat trips now is to have one of our bigger boats, ferries, converted this coming winter. That will be an over 12-seater, a 100-seater, okay, fully electric. And after that, we're going to be starting the process of converting all of our ferries and cruise boats to electric. So on the UK's first national marine park here in Plymouth, we're going to certainly have what I'm going to aim to be, and I think I will be, is the UK's first fully electric integrated ferry transport system, which is going to be an absolute beauty, working on the waters of Plymouth. So really excited about that. That's definitely the vision as we look ahead to the next 5 years. We've also had just recently completed and approved designs to build a brand new Cremel ferry, which is going to be purpose-built for the route. The first purpose-built Cremel ferry since the Northern Belle was built in 1921. 100 years, 100 years. It's going to be a catamaran made of recycled materials, yeah, composites, powered by 2 fully electric motors. So that is the plan. We're hoping to start build of that at the back end of next summer, 2022. So there's loads of really exciting stuff. Plymouth certainly at the forefront of the electric marine technology.
Advanced above and below water robots, sophisticated moored scientific platforms, state-of-the-art communication systems, ecosystem modelling solutions and remote sensing combine to deliver a fully integrated observing network, pioneering smart autonomy using ecosystem models to guide the autonomous fleet and provide a fully integrated marine observing system. State-of-the-art moored buoys provide high-resolution data 24 hours a day. The coastal buoy is the only one moored in UK waters that has the capability to profile a sophisticated scientific payload through the water column. The deployment of this buoy marks a step change in our ability to monitor and study the complex marine ecosystems off Plymouth. The buoy is powered entirely from solar and wind energy and provides a unique plug-and-play capability for third-party sensors. Coupled with the high-speed communication system and the high power availability, this creates a bespoke platform to the UK for trials and demonstration of innovative marine technologies. The futuristic fleet of ocean robots includes the recently named PML Pioneer, a 5-metre Autonaut unmanned surface vessel propelled by wave motion and has 300 watts of solar panels on deck to provide electrical energy to power the sophisticated scientific payload. The PML Pioneer has been funded by the Natural Environment Research Council, NERC, and is one of only 2 5-metre Autonauts in the UK and will be the only one regularly deployed in UK waters. The integrated scientific payload is the most advanced to be deployed from an Autonaut and includes state-of-the-art chemical sensors and a photosynthetic efficiency and rate sensor. Plymouth Marine Laboratory has also procured 4 autonomous underwater robots from EcoSub Robotics with funding from NERC, with the underwater robots having sophisticated sensors specially designed for small underwater autonomous vehicles to provide crucial scientific data. This fleet is the largest of the new generation subs in the UK and is uniquely integrated together using acoustic underwater communications. The fleet will have the ability to perform multi-vehicle synchronized surveys using the acoustic comms to also provide accurate underwater positioning. The subs can also communicate with the PML Pioneer as the vessel is integrated onto the acoustic network. Smart Sound Plymouth is the UK's premier proving area for developing, validating and demonstrating cutting-edge products and services for the marine sector. and is ideally suited for building and supporting the next generation of advanced marine technologies. Smart Sound Plymouth boasts over 1,000 square kilometres of authorised and deconflicted waters, ranging from sheltered bays to offshore hostile environments. The area's impressive variety of water depth, sea states and weather conditions are perfectly suited for conducting sea trials. Access to offshore water depths of 75 metres provides the ideal environment for trials of subsurface platforms, extending to multi-platform mission operations. Smart Sound Plymouth is home to the prestigious Western Channel Observatory, where some of the world's leading academics provide an unrivaled understanding of the smart sound environment. Smart Sound Plymouth is building facilities and expertise that offers a unique location in the UK for the development, validation and proving of advanced marine technologies. Smart Sound is accessible to all and exists to assist industry, academia, regulators, defence and certification authorities to innovate and deliver the solutions required to advance marine autonomy, maritime technologies and digitisation of the marine environment.
I'm sure you'll agree some really exciting developments there, and to talk us through some of those developments and the role that Smart Sound Plymouth is playing in the development of that technology, we're joined by a series of guests for the final Q&A this afternoon. Steve Rice and Aaron Barrett are with us from Plymouth University. We've got Conrad Humphreys from the Bounty Project, who we saw there a moment ago, Tom Rooney from Sonodyne International. We also have James Fishwick with us from Smart Sound Plymouth, and here in the studio we've got David O'Sullivan from Thales. James Fishwick, I'd like to start with you first of all, if I may, and just summarise for us Smart Sound Plymouth, how it came about and what it's capable of delivering.
So Smart Sound really was the formation of the recognition that there's a critical mass operating in Plymouth, looking at marine innovation, specifically marine autonomy and sensor technology, so making an autonomous platform useful. We've heard a lot about that today. So it really came about from that recognition of the critical mass, also in recognition of the long-standing history of organisations, specifically Plymouth Marine Laboratory and the University of Plymouth, working collaboratively with industry to help to innovate and innovation support. So Smart Sound was formed about 3 years ago. Has really become very firmly established now, I believe, as the UK's platform for innovation trials in marine autonomy, technology and digitalisation, progressively investing in more capital assets that you've seen today in some of those presentations. Also, the newest sort of addition is the Smart Sound Connect project, which is a high-speed communication system, which is really critical enabler now to how we develop marine autonomy and autonomous systems.
We've seen how busy Plymouth shipping areas can be. How does the Smart Sound area work in conjunction with the day-to-day shipping and movements of boats that go on in Plymouth?
The Smart Sound is quite a large expanse. It's around 1,000 square kilometres. It extends 20 miles offshore. So that has various reasons for that. One is that we can expose marine innovation and technologies to all kinds of marine environments, from really hostile offshore environments to more sheltered base. But it gives us an ability to move around into different areas. It's a large expanse. So one of the things that we do is we obviously communicate with the harbour master and talk to them around movements of vessels in the area. Also, Smart Sound Plymouth has a stakeholder engagement system. So we will issue a warning, or not a warning, because we'll issue a notification of our intent to do a mission around 2 weeks, 2 or 3 weeks before the mission is deployed. And that will act to do some deconflicting. So principal stakeholders are the Navy, for example, but also right down through divers, fishermen, you name it, paddleboarders, any clubs. We've got about 45 stakeholders on that list. So we do a lot of engagement around deconfliction.
Well, let's find out a bit more about how it helps in research and bring in Steve Rice, first of all, who's from the University of Plymouth. And Steve, what does it mean to have something like Smart Sound in Plymouth?
I think it's incredibly valuable for universities because in addition to being places of research, places of teaching, and as Professor Thompson pointed out brilliantly earlier this afternoon, marine autonomous systems are really valuable tools for universities. but it's always about constantly increasing the capabilities of these systems and pushing the limits of what they've been designed to do necessarily to what they're capable of ultimately, in terms of adding more and more sensing, and in the context of the communications we've been covered in our video, pushing the further reaches of how far you can go and how much ground you can cover, and as Richard said, the kind of sampling you can do. So really exciting to have Smart Sound Plymouth and that kind of pre-consented and professionally managed area to actually push these systems further.
What's it done in terms of speeding up the development of these systems? If you didn't have Smart Sound Plymouth available to test these facilities, to test this technology, how much further behind would we be, do you think?
I think logistically quite a lot further behind. I think that the advantages of having an alignment of all the people involved gives you that shared experience and the sort of streamlined approach with people, the relevant authorities, and you can benefit from one another's experience. So there are a number of occasions where we've wanted to do a physical deployment or trial or something involving our students or an industry collaborator, or we've lent on the partnerships within Smart Sound Plymouth to make that happen. That can be physical, that can be, we just don't have the right boat in our fleet available to do the thing that needs to happen on a certain day in certain conditions, and then leveraging those partnerships to access somebody else's support boat. It could be expertise behind what we actually need to do. It could be any manner of things, but Smart Sound really does enable all of this. And the collective, I think, is the real value proposition there.
Let's bring in Aaron from Plymouth University as well, technical specialist in autonomous marine systems. What role is Smart Sound Plymouth playing from your point of view, do you think, in development of autonomous systems?
So Smart Sound's very much a friendly environment for trialing new things. There's lots of, as has already been alluded to, there's a critical mass of people all trying to achieve the same goal. So, you can call on each other's relationships with various key stakeholders to bring technological ambition to life. And obviously having things that have already been kind of tried in various forms means that, latter iterations can be achieved much quicker. If we were going somewhere completely new, where nothing had been done, that would take, as mentioned, an awful lot longer.
Conrad, if I could bring you in at this point, you know these waters well. What does it mean to you as a seafarer to have this level of research going on the doorstep in Plymouth?
Well, it's very it's fascinating from a number of different levels. From the perspective of the Bounty Project, we're very interested in the sort of the opportunities with electric propulsion and with the 5G network in terms of communication and being able to sort of almost stream and broadcast live through our sort of educational platforms to schools and so on. In the future, that some of that may mean autonomy in terms of the vessels. I mean, we've integrated an electrical system into a 17th century or 18th century vessel here. You can see behind me. So, in the future, just trying to imagine what education might look like with sort of live autonomous type vessels, perhaps navigating in some of the incredible waters that Bligh and Cook and these men were doing 200 years ago. And recounting those stories back to children across the planet would be fantastic.
It's been wonderful through the Bounty Project to see that meshing of the most ancient form of technology on the water, sailing, meshed with this modern electric technology. What sort of response is it getting from the young people you're talking to?
I think it's incredible from a number of different levels. I mean, first of all, they're being inspired about these incredible historical journeys, which, if you think back 200 years ago, they were really no different from what we're seeing now. In terms of really pioneering new technologies, discovering species and places that were unknown, and venturing into areas of sort of unknown. But in terms of really bringing this to life, I mean, we have some incredible milestone events happening in the next 10 years. 200 years ago, in 2031, will be Darwin's voyage. And if we think back to when Darwin left on the Beagle, he was just 22 years old on that particular voyage, along with Robert Fitzroy, from the founder of the Met Office. You know, these people headed off 200 years ago, and we have an opportunity to sort of actually recreate some of these voyages again, but in a very smart, intelligent, and universal way, really.
Let me bring in David from Thales at this point, David O'Sullivan. We saw in that film just a moment ago some of the technology that you're trialling within Smart Sound. What does Smart Sound mean to you as a company, having that facility available?
It's really quite important to us because one of the key things for us is it puts a process in place for starters. So we know the process is developed and we've got a recognised route to be able to conduct the trials, the notifications there, which actually allows us to achieve with minimum disruptions. So that's really important. And obviously you don't get that type of, you don't get that process in all areas where we could potentially be working. I think also the collaboration within Smart Sound is really, really good. And obviously we can access experts basically within this domain, which is really, really important. And I think for me going forward in the future, the 5G network is going to be key because actually it's going to make our trials and test capability far better and far superior. Being able to have the comms network to enable that data back so we can learn quicker and actually work out where things are potentially going wrong quicker, but also rectify them better and delivering better autonomous systems. So I think that's going to be a key driver going forward, is that comms ability.
I just want to bring Tom in at this point from Sonodyne as well, because Tom, all these individual organisations and companies, you're all working in a way towards the same aim. How do you work together within the Plymouth sector? How important is that collaboration across different technologies and different businesses?
Well, I think the collaboration and the way that everyone in this room at the moment works together is really important. It's what really cements Plymouth and the Smart Sound sort of facilities as a world-leading sort of outfit. You've got the Future at Sea Technologies Cluster closely aligned with Smart Sound. The city itself has been a lot of investment in the blue economy with Ocean's Gate and Maritime Business Centre set up that really becomes kind of centre mass. It brings people to Plymouth. Now, as a commercial sort of enterprise that already has a footprint in Plymouth, what we've noticed over the last couple of years is these relationships with academia and with other commercial companies really cementing, and we're working really closely together to build relationships, to further the technology and really drive this kind of UK-centric business, business and economy through Plymouth.
And how would you say it fits into the Plymouth and wider southwest economy? What role is this sector, the marine sector that we've heard so much about today and see some amazing developments in, how important is that to the southwest economy?
It's hugely important. I mean, the other main economy in the southwest, as you know, is tourism. But the blue economy is probably the second biggest economy. You know, you've got the big companies like Thales and Babcock situated here in Plymouth. You've got all of this facility. The fact that you've got the access to deep water, open water within a very short transit time from the shore in Plymouth makes it the place to work in the maritime sector. And we really see that. We see that developing. The history, as you've seen in Plymouth, has been steeped in maritime all the way through. And this initiative, the Smart Sound facility, is just the next step on that history, really. It's going to cement our future as a city.
So, James, we've heard there from all of our guests today that the catalyst that Smart Sound is providing for so many businesses and technological developments coming out of Plymouth and the UK. What's the next step for Smart Sound? How is it going to evolve and develop?
Yeah, so I think a few people have alluded to the communication system and the platform that we're installing called Smart Sound Connect. So I think that's a real game changer and a step up really in our ability to deliver autonomy trials. Also, I mean, from the point of view of Smart Sound and also Plymouth Marine Laboratory and many others, the aspects of now how we develop that autonomy. We've heard a lot around sort of single platforms today, but really the systems of systems approach. And I think Smart Sound is ideally located, and the facilities we have really are key to be able to do systems integration. So how do we integrate surface autonomy with subsurface autonomy and aerial autonomy to really deliver a fully autonomous system? I think that's the next sort of big thing for Smart Sound, as well as moving from the above water communication system. We also want to install a subsurface, so an underwater communication and positioning system as well to develop subsurface autonomy.
Steve, let's bring you back in from the University of Plymouth and talk a bit more about autonomy and the development of that. I mean, in terms of the stages we're at with that, research stages, how would you describe the progression of autonomy? Where are we at the moment?
It's a good question, because there's the pure almost machine learning, intelligent marine-based AI questions that have been discussed quite a lot in today's sessions, excellent sessions. But what's really fascinating at university level is how broad it's gone as an entire concept. So there's been some really interesting questions and challenges that have come out of this for our students across a whole range of disciplines. Plymouth attracts culturally a lot of people willing to learn at undergraduate, or people from industry at postgraduate level come to Plymouth to do a marine-based degree. If they want to actually go and have hands-on experience in the marine environment, they do that. And we've seen already with the uncrewed surface vessel behind me, USV Cetus, and other platforms we've worked with, and with James, we've seen students delivering projects from ocean exploration through to marine sciences, but also engineering. And we're going to start seeing more in things like maritime law and maritime economics. These are areas which are really interesting. Students are leading this. When they're not being pushed towards these projects, it's just what they're doing in step with what they're seeing happening in the real world. So I think from that point of view, it's been really fascinating, and autonomy's posed lots of interesting questions beyond just the deeply technical around how the vessels themselves behave. I think this really reflects how Plymouth embraces a sort of wider picture of applied autonomy more generally at a sort of institutional level and as a city partnership as well.
Conrad, just coming back to you a moment, we saw a fascinating insight there into the development of eVoyager, the ferry developments, the electric ferry developments going on in Plymouth, and that's going to evolve. What do you make of what they're doing there with the ferries and turning the fleet into an electric fleet?
I think it's absolutely the future, and in fact, I would go further than sort of refurbing existing ferries. We actually need to design boats that are particular relevant to electric propulsion, and which means lighter foiling boats capable of getting out of the water and travelling at much greater speeds effortlessly. A lot of the big players in the sort of micro mobility area, the sort of e-propulsions, the smaller sort of 1 kilowatt type motors that can be fit onto the back of small craft. We should see the sort of the phasing out of things like the sort of 5 horsepower, typical 5 horsepower petrol motor that you might find on the back of a small yacht or as a tender. In the next few years, those will disappear, because it makes actually no financial sense to be buying petrol-based outboards when the electric industry is really thriving at this stage. And I think if we can get the infrastructure right around the port with charging systems, then we can actually start to really address the big issues of transportation around Plymouth. With a really exciting opportunity. I mean, it's fun playing around with the older vessels, and with Bounty, she responds very well as an electric boat. But I have to be honest, I think the future is in foiling in high tech and light speed vessels rather than necessarily modifying older ferries and so on.
You'll be aware, of course, that a lot of people have range anxiety when it comes to electric cars, and I assume the same applies to electrically powered boats as well. You talked there about how Bounty uses some of the wind energy to recharge the batteries. How reliable is that system? Have you tested it enough to know that this almost sort of carries on, as a constant source of energy?
Yeah, I mean, it's certainly something that has concerns for people when they're considering their options. But the first question you have to ask everyone is, what is your use case? When you jump into a a car or go and buy a car. It used to be you wanted a top speed of 120 miles an hour, and you wanted to be able to drive for 400 miles. But the reality is most people are using their cars never at those speeds. They're traveling 5 miles to work, and they're absolutely ideally suited to electric. So I think you've got to get away from the that sort of anxiety. Think about your real use case. And if you've got the redundancy there, as in most sailing boats have, then of course you sail when you're low on power and you recharge. And if you've got no wind and you're stuck in the middle of the channel, well, maybe you read a book.
As someone who's taken on some of the toughest ocean challenges, how do you feel as a seafarer hearing about all this autonomous technology being discussed today and taking human interaction out of the equation altogether, or pretty much out
I'm a big fan, actually. I mean, autonomy's been around in my discipline since, for the last 20, 30 years. Single-handed sailors rely on highly sophisticated autonomous instrumentation within the boats. And in fact, everything bar making the final decision in terms of navigation is done from autonomous systems, self-learning systems on board these boats. And actually, we've seen now 2 editions of the Vendée Globe with boats circumnavigating without the use of fossil fuels. And so if a boat can go around the world in sub 100 days without burning any fossil fuels, with electronics really paving the way for them to be able to do that, then I think we're very close to seeing that being rolled out in a more mainstream way, and it's great that Plymouth could be a real test bed for that.
Aaron, I wonder if I could bring you back in from the University of Plymouth, because what's occurred to me is, and Conrad alluded to it there, there's been a certain level of autonomy on boats and aircraft with automatic pilot. Cars have cruise control. There's a certain amount of autonomy that's been around for a long time. Why do we need to develop it any further than we currently have?
So what we're doing here is we're opening the can of all the sort of various nomenclatures and the way we describe things. I mean, it's very true that boats have had autopilots for a long, long time. Often when we use the term autonomy, we tend to mean uncrewed, but the problem is that might not always be the case. So not all autonomous vessels are uncrewed, and not all uncrewed vessels are autonomous. And so effectively what we're doing is we're widening the remit of possibility. So as Conrad rightly said, you have systems that drive boats with people on them. We're looking at systems that have no people on them. We're looking at systems that have no people on them and have some degree of decision making themselves, and systems that have no people on them and are completely controlled robotically. We're also looking at systems that have people on them, but are also, controllable in a hybrid way, in a multitude of different ways. So like Thales, for example, as your other guest there could describe in detail, their systems are able to be crewed or uncrewed, can be controlled from the shore or from the actual bridge. And it's about giving that real smorgasbord of flexibility, which is going to empower the industry, that I think is what we're aiming for.
Let's bring David back in on that from Thales's point of view. How important is it to have that mix, a sort of ability to have that flexibility of full autonomy or part autonomy?
I think it is important, and as well, listening to our customers, they vary. People want to embrace full autonomy, and then there is the hybrid model as well with manned crews. It is quite interesting though, because obviously one of the downsides of having a hybrid approach where we can actually man it, we then have to build a vessel that's then got a wheelhouse to protect the personnel. We have to put windscreen wipers on the windscreen. We've got to put control mechanisms in there. And actually, what it does do is actually drive cost into the solution.
Crew accommodation, I guess.
Yeah, so it's all of these other factors as well. So eventually, I can envisage potentially a full embracement of full autonomy because of the cost drivers with it. And it's probably dependent on the complexity and actually what mission objectives you're trying to achieve as well. And I think going back to my presentation earlier, I think we've got to go on the trust journey first. So really, and one of the benefits of having the hybrid approaches is that we can go nicely on that trust to gain that trust. But I do think it's interesting times. I think maritime autonomy is in probably a far better position than what we're seeing in the land domain, where we're looking at autonomous vehicles. We've all seen, I mentioned it earlier on today, the problems, all it takes is one single incident with one of the Uber cars, and then literally it sort of brings things to a grinding halt. So actually taking this hybrid approach with the right people as well, because it's got to be the right people that understand the technology, that's sat there babysitting this, then I think it will actually help us accelerate the maritime autonomous sector.
And trust in the technology has been one of the key themes today. Clearly, a lot of the work that goes on smart sound, in testing this technology, is vital in improving people's confidence. Tell us a bit more about the role that smart sound is playing in helping in that crucial element of building trust in the technology.
I think it's data-driven, basically. So obviously it allows us to extract more data to actually present how this system is actually truly working. It also gives us control mechanism as well. If you've got a good communication and it's far-reaching network, we have got the ability to take back control manually, even if it is remotely, even if it is unmanned as well. So I think there's multiple strands of why smart sound, and particularly the comms element, is really key to driving this technology forward.
And that's where the 5G comes in. James, if I could bring you back in. I know there was some concern earlier from one of our questioners about how long the 5G trial might go on. I mean, have you got any ideas? Can you give us an insight into how the 5G trial is going to develop?
Yeah, so you're correct that the initial 5G project is a private marine network across the Port of Plymouth for a 12-month demonstration period, going live in August, July, August this year. But there's plans afoot to increase that and to find the funding source to deliver that into the future. I think Richard May alluded to it earlier on this morning. There's not only interest in building the longevity of that network, but also increasing the range, taking 5G offshore. So really being a hub in Plymouth for how we innovate and deliver 5G solutions in the marine environment. So yeah, a 12-month initial project, but through Ocean Futures, the initiative which brings in smart sound and various other innovations around clean propulsion and digitization, there's some key aspirations around generating the income to deliver a longer-term 5G solution.
And I want to develop this theme of trust in the systems a bit more and bring Aaron back in from the University of Plymouth. Clearly your work is trying to make the technology work and make it as robust as possible, but how much of your work is also in building trust in the systems?
I would say that's the majority driver. I mean, the point is anybody can really build an autonomous vessel. All the parts are easily available on the internet. You could throw something together in an afternoon. You couldn't make it reliable. That's where the real engineering challenge comes in, is how to make this reliable to a point where it will convince very, very skeptical, rightly skeptical, stakeholders that are in charge of safety, such as the Queen's Harbour Master. How are you going to convince that office that you're not going to cause a major incident with your, highly experimental technology? And it's a road where you have to map everything you do. You have to have contingencies planned for every single step you make. There can be no, as you say, as we alluded to with an Uber car crashing into the side of something and causing a fatality. It would set the industry back. It would set Plymouth back and this whole project back a long way. So we have to make sure everything is as watertight as possible.
And how far along that route are we? I mean, how far away from people having absolute trust, faith, and confidence in autonomous systems are we?
It depends on the level. It depends on what you're trying to do. I mean, by using the term autonomous systems, as you probably can appreciate from the Expo today, there's a vast sort of spectrum of possible operations, from very, very close inshore where you have a support boat and a small vessel next to it doing multiple multi-beam surveys. I mean, that's tried and tested. People trust that. The possibilities of things going wrong there are very small. However, if you were to, say, produce an uncrewed oil tanker and send it all the way across the Atlantic on its own, that's a very, very different kettle of fish, and we're a long way from that. So it depends where you are on the spectrum, really, with the degree of confidence that currently exists. And our goal, of course, as research and development, is to push that boundary of faith and confidence that these systems are safe, reliable, and do save time, money, and make the health and safety case better.
Tom, how far along that route do you think we are in terms of building people's confidence and trust in these sort of systems?
Well, I think as Aaron alluded to there, it does depend on the level. You know, there are systems already operating out there in the commercial zone that are fully autonomous, but they're not necessarily dynamic. You know, we make a lot of autonomous systems that sit on the seabed and gather data without moving anywhere, and they're no risk at all. And they've been used for years, and everyone widely accepts that. In the underwater realm, you know, with UUVs, they're being used autonomously, but across all sectors where these vehicles are deployed, sent off on their own, and then they kind of hope that they'll pop up where they expect them to be, and they do. What we're doing in Plymouth in the smart sound area is to kind of make that more reliable, you know, so that they don't have to rely on trust that the vehicle is going to pop up where they think it is, you know, where it thinks it's going to be, where, you know, the ability to work collaboratively to put our sensors onto other people's vehicles and vice versa, in order to make sure that these systems are more reliable and predictable, and they can also monitor them from afar if necessary, using other assets. And this is what James is alluding to, and being able to use multi-domain assets in one arena to fully test that, to build that trust, is a crucial part of that step along the road. And
it's a virtuous circle, I guess, in that the more you build trust and confidence in this sort of technology, the easier it is to get people to invest in it emotionally and financially. And what are the challenges at the moment in terms of getting people to invest in the technology?
Again, that's that culture and that trust again, exactly what you're saying. It's when people recognize the benefits, they recognize the fact that if you have uncrewed systems that can either be remotely operated in a hybrid way or fully autonomous, you can do more with them in environments and conditions that you can't send a human being. But so the commercial side of things, and also increasingly the defense side of things, recognize the opportunities that these type of platforms offer. The ability to go where you couldn't go normally, as someone said in one of the presentations earlier, you know, putting technology where a human being physically can't go, to work in environments and conditions that a human being would find it incredibly uncomfortable or almost impossible to work. And in so doing so, these platforms are smaller, cheaper to build, more economical to run. You don't need to build in order the human element either. So that's part of it. People recognize the benefits, they start buying into the concept, and therefore they start going along that trust path with you.
And James, in terms of investment in smart sound, how much of a challenge was it to get the investment, to get it up and running? And what are the continuing, I guess, as it proves itself, and it's clearly very popular among the people we've spoken to today, but in terms of convincing those who helped to fund it, how successful are you in getting the funding?
Yeah, so in the early stages, I think you're correct. It was kind of difficult to get the funding. We're very fortunate that the main collaboration of Smart Sound joined forces and wrote a European Regional Development Fund proposal, which was a 3-year funded proposal through for a project called the Marine Business Technology Centre. So that allowed us really to get a lot of the funding. The USV CETUS and one of our advanced data boys came through that avenue. And then over that period, that's allowed us to generate the support, and the support is significant. When we go to investors, you know, to show the level of support and use for smart sound and the real ability and game-changing ability it brings to marine innovation autonomy, really enables us to convince those investors. So recently we go through a whole spectrum. The Smart Sound Connect is funded through the local enterprise partnership, and some of our new facilities are funded through the Natural Environmental Research Council, interested in scientific exploitation of marine autonomy. And going back to something that you were just talking briefly to with Tom and around investment and the potential for marine autonomy, I think one of the game changers that has been discussed a little bit today is around our abilities in net zero. So the autonomy and the platforms really do deliver that ability to move towards a more net zero environment and aspirations around the 2050 agreement. So a lot of investment is expected in this area.
And Steve, we know that research can bring with it investment opportunity as well. How important is it to have the facilities that we've discussed here in Plymouth today in terms of attracting further investment in research?
It's crucial, and more than just the investment. The investment's a really critical component. So is the expertise. What we're looking at here is a proposition with all of the equipment and all of the infrastructure that's in place is an incredible sort of marine research playground, if you like. We have some, fantastic expertise. It's been said a few times today about the community of leading marine research organizations in the city, university being one of them. But there's so much more fantastic work to do that people who choose to perform their research and collaborate with the city will have that unique ability to do, thanks to all of this investment and all of these incredible assets and technologies. And it'll only improve as the student population and young researchers thrive, and we start to feed that back into the supply chain and the industries that are here today to provide the kind of technical solutions that then fill the gaps. And you've got that cycle then where when the gaps are filled and we can do more, the research expands, and so it goes.
And where is that research going? Where are your students taking that research? Because we're obviously focusing particularly on the marine sector today, but the applications that we're discussing could potentially be used way beyond the marine sector. So where is the research taking autonomy further beyond the marine sector?
That's interesting. And I think actually James and Tom touched on that as well with this discussion of net zero. So on a pure technical basis, like you say, in marine, we're looking at things like moving from the early stage adopters like geospatial and hydrography, moving into things like mechanical design engineering to solve some of the more technical issues with marine autonomy. But outside of marine, there's all of this kind of impact. So when we talk about the positive impacts of adopting alternative forms of propulsion and energy mixes on platforms, that's transferable technology. So if you're talking about having a number of different ways to power things on a platform or a system of systems, that then can feed back, if you make great headway, into terrestrial platforms or aerospace platforms, space sector. And we're seeing more and more of that in the Southwest now with some of the new projects that are being announced and major infrastructure deals being announced within Devon and Cornwall. There's a lot of space marine overlap potentially happening, which is quite exciting.
And David, here in the studio with me, we heard there about the development of autonomy helping towards the targets for net zero emissions. How much does that focus your work at Thales, the idea of reaching net zero emissions?
No, it is quite important to us. You know, obviously social values are key going forward. And I mentioned earlier on in the presentation that we're looking at our next generation USVs, and I can't go into too much details today, but obviously, you know, the net zero is a key driver as part of the requirements for that. So it's basically, it's coming to defence as well. It's not unique just to the civil sector. We've all got to embrace that net zero policy, including defence.
You've worked in this sector for lots of years, I know, in different forms and guises. What's it like working in this sector at the moment in 2021?
It is very, very exciting because obviously for me, being a traditional platform-based person, to be actually able to see taking the human risk, being able to, you know, rather than put a traditional platform into a minefield, put an unmanned asset into a platform, but more importantly, those unmanned assets and these payloads are actually achieving better output than the manned platform for less. So there's less personnel involved, there's less cost, and we're actually getting better results. So it's quite exciting, and this is only the start of the journey as well. And I think that's the important part, and it's accelerating rapidly.
Let me put that question to all of our other guests as well. Conrad Humphreys, first of all, what's it like being part of the maritime industry, this sector, in 2021 in Plymouth?
I think we're just about to go through an incredible growth period, not dissimilar from what we've seen with the automotive industry. I think now the kind of stick has come there. The stick will come eventually for the marine sector as well, and micro mobility, particularly for Plymouth, could be really revolutionise the transport around the city, and also, you know, for people getting out on the water, just generally getting access, enjoying themselves in the leisure industry, and feeling good about what they're doing. I think it's going to be tremendous growth over the next few years.
And James, what about you? What's it like being at the forefront of this sector at the moment?
It's a tremendously exciting place to be. I love my job. I'm very fortunate in my job, and the ways forward and the things we're doing are really exciting. From PML's point of view, how we look at observing our marine environment in a more sustainable way. So the assets that we've recently procured, looking at the net zero oceanographic capability, but not only in a net zero, some of our subsurface assets, we're looking at how we can less intrusively sample the benthic environment, for example. So where in the past we would have stuck a big corer into the seabed to get a whole section of seabed and bring it back up onto the boat, we're looking and exploring now future projects of how we can use our subsurface assets to do less invasive sampling sampling, and then how we bring the data set. So for us, autonomy opens up a whole new avenue in the size and the frequency of our data. So whereas before we'd send a vessel out and take a suite of data, now we have data 24 hours a day, 7 days a week, the game-changing data. We're looking at now, PML have just invested £1 million in a new GPU supercomputer for artificial intelligence and machine learning. So how are we going to deal with all that data? How are we going to interpret it? How are we going to visualize it? How are we linking it with satellite remote sensing? How are we linking it with our world-leading environmental ecosystem modeling groups? And how we can use those ecosystem models to actually direct the autonomous assets to interesting locations. It's very exciting.
And Tom, as someone, a business that's been part of this sector for quite some time now, how does it feel for you personally to be involved in this kind of technology in 2021?
Well, I think Sonodyne have been operating, had a trials facility in Plymouth since the early 90s and quietly running high-tech trials here, without under the radar, so to speak. Not quiet anymore, is it? I mean, Plymouth has suddenly exploded over the last few years. We're seeing a lot more activity in the maritime sector. It's a really exciting time. There's opportunities for businesses across all parts of this sector. We've already heard, for alternative propulsion, for fabrication, electronics, computers, cybersecurity, as well as all of the maritime sensors and systems that are associated with these platforms. So we see it as a great opportunity to collaborate, work with more people, and further cement these really good relationships that we've built here in the city for everyone's benefit.
And Steve, from a research point of view, what's it like being part of this sector, this wider industry in 2021?
To add to all the comments made, it's personally really exciting. I think what's changed is Plymouth's always been at the forefront of what's happening in marine and maritime. And from a research perspective, that's very much true for the university. I think what's changed now is all of this infrastructure, all of these collaborative projects and initiatives create a kind of new critical mass that takes us to a point where we can address really head-on some massive global challenges. So things like offshore renewable energy, large-scale developments, things that are close to home, like the idea of floating offshore winds in the Celtic Sea. These are realistic propositions we can really tackle head-on across all disciplines when you have the right tools and the sort of foundation to build from. I think that's really exciting.
It's really good to get all your thoughts on all the subjects we've talked about today. Steve Rice and Aaron Barrett from the University of Plymouth, Conrad Humphreys from the Bounty Project, Tom Rooney from Sonodyne, and James Fishwick from Plymouth Marine Laboratory and Head of Smart Sound Plymouth. Thank you very much. And David O'Sullivan from Thales here in the studio, thank you for joining us as well. And that concludes Marine Tech Expo 2021 from Plymouth. Thank you very much to all our guests, and I hope that their conversations will spark further conversations and innovations all over the world. We hope to see you next year in person, possibly, but in the meantime, from all of us at Marine Tech Expo in Plymouth, thank you for taking part and goodbye.